In this video, we're computing the integral of the inverse sine of the square root of 1 minus x squared. And the natural first thought here is if I could turn that square root of 1 minus x squared into the sine of some angle, then the inverse sine would undo that. And the idea is to use a Pythagorean identity here. We're going to let x equal cosine theta, so that when we square it, we get a 1 minus cosine squared inside the square root. That reduces to sine squared. When we take the square root, we get the sine function, so we're making progress. And we need to transform the differential dx as well, so that comes out to negative sine theta d theta. So we make our substitutions in the integral, and again, the plan is that 1 minus cosine squared reduces to sine squared. We take the square root of that, and we have the inverse sine of the sine of theta. And I'm sure there are some interesting domain issues going on here, but we're doing an indefinite integral, so we're not going to worry about it in this problem. The inverse sine of the sine of theta just gives me theta. And we arrive at a classic integration by parts integral. So for the integration by parts, we're going to let u equal theta. And this means that du is just d theta. And then dv is the rest of the integral. And I'll go ahead and incorporate the minus sign that was out in front of this thing into dv. I'm going to say dv is negative sine theta d theta. Just so we don't have to worry about remembering to distribute the minus sign later. And this means v is going to be just the cosine of theta. All right, so we apply the integration by parts formula, and I start out with a u times v, that's theta cosine theta, minus the integral of v du. And the integral of the cosine function is just the sine function. So I arrive at theta cosine theta minus sine theta plus c, but we're not done yet because we have to rephrase this answer in terms of the original variable x. So we go back to our substitution, x equals cosine theta, and this means theta is the angle whose cosine is x. In other words, the inverse cosine of x. And the challenge is that we have to evaluate the sine of this angle. And for this, we use a right triangle. I visualize the angle theta. There's the angle whose cosine is x, which means the adjacent side is x, the hypotenuse is 1. And to get the sine of theta, we need to get this opposite side of the triangle. And in this case, I'm going to accomplish this with just guessing and checking using the Pythagorean Theorem. So I've got to find the expression that when I take x squared and I add it to the square of this expression, I end up with 1 squared or 1. And putting a 1 minus x squared inside this square root gets the job done. If I square that and add it to x squared, I get 1. So I transform my answer back in terms of x, and theta is the inverse cosine of x. And then the cosine of theta is just x itself. So I'm going to put that in front, x. And again, theta is the inverse cosine of x. And then I have minus the sine of theta, which is the opposite over hypotenuse in our triangle. That's a square root 1 minus x squared. And we carry that plus c, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.